So I'm going to be talking today about improving fire safety. I'm going to be talking about how collaboratively, when a number of organizations work together, we can work together to generate new knowledge and really lead to impact. So I'm going to do this by going over the general process for performing collaborative research work at BRE. And then I'm going to just give you a couple of examples of how collaborative research work was performed at BRE and the outputs that it's led to. And then I'll take you through one of the current projects that is currently taking place, which is the causes of fire fatalities in Scotland. And then I'll be looking to the future to see what research work we're looking to engage with, see if you're interested in participating in that. So I've got this flowchart here, which summarizes how we perform research work. It's like the basic framework of performing research work at BRE. So it typically starts with an idea. A group of people get together and agree that this research would be valuable and it has certain objectives we'd like to achieve by performing this research work. And then a number of organizations, partners, will contribute towards that research work. So the Trust will always, hopefully, continue to support me with these projects, put in a cash sum, and then other partners put in either cash or in-kind contributions in terms of their time, equipment, or data, and then some partners may choose to do more than that, whatever else they can do to support the project objectives. So then once that's agreed, BRE then performs the research work. And I've got this little blue line going back up there, and that's just to show the fact that whilst BRE perform the core of the research work, engaging with the partners when needed, at every stage or every milestone of the work, that work is reported back to the partners to say this is where we are and this is the direction we're going. So everybody is going together on this journey and agreeing with the outputs that are coming from that. So that leads to new knowledge, which is brilliant. And from that new knowledge, there are a number of impacts that can result. Some of those include public guidance. So we produce videos. If you might have seen some of the videos running here, that we certainly be running in the Chaucer room next door. And then there's briefing papers. We generate freely available briefing papers, printed copies and PDF versions on our website. And then we always produce articles in the trade press to ensure that there's maximum impact. People are finding out about the work that we're doing and what it's led to. It can lead to improving processes, so that can be for the partners that have been involved with it, like the fire and rescue services, or for manufacturers to improve their processes for developing their products. A lot of the time, the work that we perform leads to new knowledge that can be used to either support the development of new standards or to revise existing standards and codes of practice. It also can help our manufacturers to improve products. And then also in terms of developing services, we as BRE, because we perform testing and certification, if we generate some new knowledge and are able to develop a new standard under our own name, a loss prevention standard, then we can certify products to our own standards. So again, that's very impactful in terms of not just performing research work and then leaving it there, but in terms of performing research work, being able to develop a standard, being able to develop the service to offer testing and certification service to that standard, manufacturers coming to us with their products, certifying those products, and then actually them being implemented. So, you know, we're in that whole loop from the outset. And so obviously, another great thing that comes from this is more research work, which as a researcher I love. And that goes back, and we go through that same loop again, really, of finding more partners to get involved in research work, new knowledge, and so it goes on. So I'm just going to take you through a few examples of how that's been performed. So there are a couple of studies that were performed in the past looking at the causes of false alarms in buildings and specifically trying to work out how we can reduce them. So the first study, the one that's shown at the back, the causes of false fire alarms in buildings, that was very much done on quite a small scale with a few collaborators involved with that. But it had some interesting impacts, and perhaps one of the most important recommendations that came from that was that if you really want to understand the causes of false alarms, and if you really want to reduce them, what you need is someone like a technical expert, someone that has an understanding of fire and of fire systems to accompany fire and rescue service staff whilst they go and attend false alarms to really get down to the nitty-gritty of why did those false alarms occur. And so that study, so that was one of the recommendations that came out of that, and Scottish Fire and Rescue Service and the Fire Industry Association, the largest trade body in the UK for fire, they were very keen to take this forward. So together with another group of stakeholders, we agreed a project and how that project was going to be performed. So with such a comprehensive stakeholder group, that was reflected in the findings from that work. There were 35 recommendations that came out for that, for all different stakeholders can do to reduce false alarms. And in terms of impact, one of the things that came from that was that manual call point covers, which were responsible for, I think, about between 10 and 15% of false alarms. If they had covers on them, they would certainly help to reduce a number of those false alarms. And so that was fed into the Code of Practice, BS 5839 Part 1. So I've shown there a manual call point with a cover on it. So that's now a recommendation within the Code of Practice that when you install a manual call point, you put a cover over it. So there's an example of actually leading to impact from the work. So it's helped to provide guidance to fire and rescue services, to organisations on what they can do to reduce false alarms. It helped us to develop a service at BRE to actually investigate false alarms, and we've done that for a couple of organisations where we've been to their sites and looked through their records and through their data to identify ways in which they can reduce false alarms, particularly high-profile ones like airports. So the study was performed in Gatwick, sorry, not in Gatwick, in the Greater Glasgow area, and it helped to reduce alarms, false alarms from that over the period since it was done. So it's about 4 or 5 years ago it was done, and I believe there's been about 4 or 5% reduction in false alarms in that area, which is, again, is a great outcome from the work. One of the things that came out from this was that further research work needed to be done into multi-sensor technology. So I'll speak a little bit about multi-sensor technology. So multi-sensors are detectors that utilize a number of different sensors and can detect a fire more reliably. So they can typically have a carbon monoxide sensor, a smoke sensor, and a heat sensor. And by working together, when there is a signal from all of them, it's more likely to be a fire. If there's a signal from just one of them, it's more likely to be a false alarm. So by using the sensors together, and in an optical heat multi-sensor, it has an optical and a heat sensor, you can actually more reliably detect when there's a fire, but also hold off when there's just one single source, thereby reducing false alarms. So as part of that study, again, the Fire Industry Association supported us with that, together with the BRE Trust and a number of different manufacturers, and we performed a comprehensive study where we tested 35 different smoke alarms and detectors that are available in the market today. We did a comprehensive test program where we did 5 false alarm tests, 10 different fire tests, some of them more challenging than existing test fires used in standards. And the key findings from that were that smoke detectors and multi-sensors are actually a very similar performance to fire, which is a great finding because that shows that the standard is standardized. You're having a very similar response, and the expected response you'd have to different types of fire. They're performing very similarly. But where multi-sensors demonstrated their own capabilities more was in terms of their resistance to false alarms. When the false alarms sources were put on, they were significantly less sensitive to operating. So the impacts from that have been it's led to manufacturers being able to improve their products, and it's also supporting the development of a loss prevention standard. So in due course, we will be offering a testing and certification service for false alarm resistance. So these links that are here at the bottom, if you click on those, go to those links, you can get copies of those briefing papers for free. So to give you another example of some research work we've been involved with, this time in fire warning. So visual alarm devices are used in buildings to provide warning for the deaf and hard of hearing, also in areas of high ambient noise or where you require a silent warning. And they're used to alert people visually that there is a fire taking place. So this was initially a privately funded study where a manufacturer felt that with technology of LED devices improving significantly over the last few years, he felt that LED technology would be more efficient and energy efficient, could also offer the same level of warning as a xenon device. So xenon devices generally give a very high peak, a high intensity of light. And he felt that the technology has sufficiently advanced in LED to be able to match, if not better, xenon devices. So we did a research program with this organization, and indeed we did demonstrate that when there were faster, shorter LED pulse durations, they were actually as effective as xenons in terms of warning people. So a briefing paper was published, some codes were updated, particularly in the States. They used this research work to specify shorter pulse durations for LED devices. And really what this research work did was it really raised a lot of questions as to how can you more effectively use visual alarm devices? How should we be sighting them? And so a lot of different organizations, I think there's about 15 different manufacturers of these products, have come together and are performing a collaborative research project looking at the overall way of implementing these devices in ways that they are more effective. So we're looking at such things as how does the different color, both in terms of the light that's produced, but also of the kind of the furnishings and the colors of walls, how does that affect the effectiveness? How do the illumination levels when it's dark and bright, when the sun comes out and shines through the windows, how does that affect how people respond to the light? How do people respond when they're facing the visual alarm device and it's flashing into their eyes, and also when they're facing away and it's flashing onto the walls? Do they see the reflected signal? So it's led to a lot of questions, and there's a study now in progress looking at that. So just to talk you through one of the current projects, so there's been a decrease in fire fatalities in the United Kingdom over the last, particularly over the last 35 years. And you can see the trends there. England is shown in the top right and Scotland is shown below. And there's a general trend downwards. The blue is for in domestic dwellings. And that's been largely due to three key reasons: the increased use of smoke alarms in homes, the increased the use of the furniture and furnishing regulations, 1988, and measures used by the fire and rescue services, which is fire safety checks. And these all have led to this gradual decline. But as you can see, it's kind of plateaued. And so the aim of this research work was really to identify, if it's plateaued, is there anything that we can do further to bring those down? With huge advances in technology and smart technologies and digital products over the last few years, is there anything that can be done in that realm that can help to bring those down further? So again, this is a project that the Fire Industry Association were very keen to support, as were Scottish Fire and Rescue Service, Scottish Government and the Trust. So the aim of this work was to identify what are the conditions under which fire fatalities occur and serious injuries, because serious fire injuries are kind of near misses to a fire fatality. And then really to try and use that data to propose solutions of ways in which these may be reduced in the future. So it's a two-phase research project looking at the database that are gathered by Fire and Rescue Services, which is called the Incident Recording Database. And that for every event that Fire and Rescue Service personnel attend, they have to fill out quite a comprehensive form documenting what happened during that call-out. And so for a period of 4 years in the Greater Glasgow, in the whole of Scotland, we looked at over 19,645 incidents, looked in detail at 126 of the fire fatality data, and looked at an overview of the serious injuries data. And then the second phase really is to go into a lot more depth. So whilst that form is kind of almost like when a fire and rescue service person has been to the fire, this is what they think happened at the time. When there's a fatality, fire investigators actually have to go there to work out what actually happened, and that's a lot more comprehensive in terms of working out why somebody died and what were the things leading up to that. So that's the second phase of the work. So the methodology was to take 38 questions from the IRS, the Instant Recording System, and it was looking at the kind of general conditions under which it happened. What was the type of property? What were the details around the fire discovery? Was there an alarm system present? Did it operate in time? Was it heard? What was the cause of the fire? What was the initial ignition source? Were there any impairments of the people that were present there? Were they under the influence of drugs or alcohol or under medication? Were they asleep? How did the person move during the fire? And what was the cause of the fatality? And so we looked at a number of different questions from the IRS and compared them. So by looking at those 19,000 odd cases, we've got a baseline of what the expectation would be. And then we looked at how is the deviation from that for the fatalities and the serious injuries. And from that, we were able to identify some of these findings that are summarized here. So the fatalities generally more likely in people that are age 60 or above. if they're asleep or falling asleep, whether they have underlying medical conditions and are on medication. Smoking was a big factor. A lot of people, there's a lot of ignition sources were actually due to smoking and people falling asleep or being under the influence of alcohol. Excessive and dangerous storage was something that was contributing to the rapid development of the fire. Having a physical mobility, whether it was temporary or permanent. And there's a real correlation in terms of if somebody lived alone, there would certainly seem to be higher incidence when people were living alone. And also when people are suspected to have impairments due to drugs and alcohol. And so very clearly from this kind of profile, it emerges that smoke detection alone, even the best type of smoke detection, is not going to be very effective at warning people if the alarm goes off and nobody responds to it and everybody ignores it. So more interactive solutions have been proposed for future technologies that may help to drive down fatalities. So I'm not going to go, I've not got all 14 listed there, but there are 14 main ones that came out, and some of them are shown here. So the greater use of things like smartphones, where you can get an alarm signal from your smoke alarm to your smartphone. Increasing the sensitivity of smoke alarms at night, so a lot of the fatalities occur at night. The likelihood of false alarms is less at night because people are actually generally asleep. So there's something there. And then alarm receiving centres, which are used for commercial premises. Commercial premises are linked to an alarm receiving centre automatically, so that when they receive a signal, they send that on to the fire and rescue service to say there's been a fire reported. So linking high-risk domestic people of high risk in domestic properties direct to an ARC would also help. So over time, BRE have developed LPS 1655, which is a water mist system to provide personal protection. So it's like a small zone. It's shown in the bottom right there. So you can see it in the back. There's this water which is kept inside this little reservoir, and there's a spray nozzle at the top. And that operates automatically when two of the smoke detectors locally operate. And so that water mist produces is just meant to cover that one zone and will put out a fire within that zone. And LPS 1655 is very stringent tests where the effectiveness of that system is tested by having different types of fires and seeing when does the system operate and does it actually put out the fire. One of the other areas that I'm very interested in is the use of video analytic technology. So video analytics could be in terms of using the data from a camera, which is basically operating as a sensor. It's just looking at a space, and it's looking out for characteristic signals within that. So if it sees what looks like the profile of fire, like smoke moving in a certain way, then it could recognize that, and then it can potentially send out that as a live feed to fire and rescue services. Similarly, if somebody trips over, then it could recognize that signature characteristic of somebody tripping over. Or if there's somebody trying to break an entry, again, it can be programmed to recognize these things and report these as required. So one of the other things that came up was the electrical fires. Potentially, there's a lot of research that shows that a lot of the fires are coming from electrical sources. And so there's a research project proposed, really, that maybe we should look at the signature characteristics of electrical fires to see, is there something that we can tell on the mains before a fire actually happens? Is there something that we can say that this is drawing more current, or it's drawing current in a characteristic way that's representative of a potential fire? So those are different things that have come out of this. The briefing paper was published in December last year. So the next phase is now actually looking at the 126 fire investigation reports of the fatalities, and is going to focus on the finer details. So whilst we're performing that, we're going to see if we can identify further ways in which these can be reduced, but also it's a good opportunity to look back and say, well, we've proposed 14 recommendations. If those had been in place in the case of those 126 fatalities, would they have worked, and how effective would they have been? So that's what currently I'm looking at. In terms of future projects, so these are a number of areas that we're exploring, and we're seeking collaboration for research work in these areas. So heat alarms in domestic kitchens. So most of you hopefully have got heat alarms installed in your kitchens. And what is expected that with time, there is the buildup of dust and contamination and oil from cooking. and that could potentially degrade the response of the thermistor and give a later alarm. So some research is proposed to look into that in further detail. The dangers of carbon monoxide in the home, so there's approximately 40 deaths per year attributed to carbon monoxide poisoning. And so this is a research project that's proposed to look at what are the underlying causes of that and how does carbon monoxide move when different things break down, like boilers, and when would that lead to a fatality? So what's the best way to really deal with the dangers of CO in the home? And sometimes CO can come from next door as well. It can go through walls. So how can we most effectively protect ourselves? There's another project proposed for the optimum smoke and CO detector spacings in commercial environments, capabilities of more complex multi-sense technologies at detecting fires, and also to try and expand the research work that's been done on the fire fatalities to look more internationally at different studies. And as I was saying earlier about investigating the mechanisms for signature characteristics of white goods catching fire. So if you're interested in participating in any of those projects, you know how the work is performed at BRE, so just please contact me. My details are there. Feel free to connect with me on LinkedIn if you'd like. And there are a number of limited number of free printed copies of the briefing papers available for those that are interested. So thank you very much.
Thank you.